Welcome back to the lab. This is part 2 of our 3-part deep dive into every core Node-RED node. In part 1, we covered the common and function nodes, the everyday essentials. Now we're moving on to the network nodes. This is the communication layer. These are the nodes that let Node-RED talk to the outside world, so think things like MQTT brokers, web APIs, Websockets, and raw TCP and UDP connections. If you're building anything that communicates over a network, which to be honest is basically everything in Node-RED, you need to understand these nodes. So coffee, are you ready? Let's get into it. Let's start with the TLS configuration node. This isn't actually a node you drag onto flows, it's a configuration node used by other nodes for secure connections. Basically, if you need to connect to something securely, like connecting to an MQTT broker using MQTTS or a website using HTTPS, you'd configure a TLS node with your certificates, keys, and SSL options. Then in your MQTTP or HTTP request node, you select that TLS config and boom, encrypted connection. You'll see this in the configuration sidebar when you're setting up nodes that support secure connections. It holds all of the security credentials so you don't have to configure them repeatedly. In short, TLS nodes enable encryption by providing SSL credentials. Let me do a quick demo for you. Okay, so configuration nodes don't live on the canvas, they live on the sidebar in the configuration nodes panel. Usually that's open by default, but if it's not, you just click on the little cog in the corner and it should appear. So when you mouse over an existing configuration node, you'll be able to see where they are on the canvas, which is quite handy. You can see it highlights there, look. So I'm going to show you a really quick demo about how these work. So we've got two flows here, and they're both doing the exact same thing. So this one is going to self-sign.badssl.com, which is a real URL you can go check out. It's handy for like testing connections, that sort of thing. This one is using a custom SSL TLS configuration, which is pointing to this strict configuration node. If we go to the lax one, that's doing the same thing as well, going to self-sign.badssl.com, but this is going to the lax configuration node. So if we look at these nodes, the strict one is verifying a server certificate. The lax one is not verifying a server certificate, but other than that, they're identical. So if we click on try it strictly, that will fail because it can't validate. When you try to verify the certificate, it's not there, didn't work. No guys, sorry. Click on try it loosely, this is going to the lax one. It's not going to validate the certificate exists. And then it connected fine, no problem. Don't worry about it. Don't worry about it, dude. It's totally fine. So let me quickly explain to you what these do. So when you click on a configuration node, you're not seeing a Node-RED thing really anymore. You're seeing the properties of the thing you're configuring. So here we are configuring SSL certificates. So these are properties related to SSL certificates. There's different types of certificates. There's individual files, which is just your regular SSL certificate. There's a PFX/P12 file, which is a more secure version of an SSL certificate. I've never used one myself. They're a little bit overkill for the sort of thing I do, but Google it. Or you can set an environment variable. So instead of uploading the file, you just add the values in directly. So if we go back to individual files, this is just the option to upload your certificate and your private key and your passphrase. You can also upload a certificate authority certificate to validate that it is actually a valid certificate. And then again, you can verify the server certificate, set a server name, or use the ALPN protocol, which I have no idea what that is. Go Google it. This isn't a video about SSL, this is a video about Node-RED. So yeah, that's just how you configure the SSL node, which is really straightforward. So if we drag another HTTP request node in, and then click on that, by default, it doesn't actually even look for a configuration node, but you can set one by clicking use custom certificate, and then you can either choose one that you've already created, or you can create a new one. You could also use configuration nodes within configuration nodes. The TLS one is a good example of this. So let me drag an MQTT node in, and you'll notice when I drag this in, it has a little gnome hat, and this is telling me that there are invalid properties. Whenever you see a little red triangle on a node, it's just saying something hasn't been configured properly. If we double click on there, we can then choose a server, because one of the things it's complaining about is that it doesn't have a server. And we can select, I'll set up a server here. We can select our existing server, or we can add a new one. We'll ignore the topic because that's not the point of this. And then if we go into our secure broker server, our MQTT server, this is the configuration node for the MQTT server we selected. And if you see, we've got use TLS here, and that allows us to select our TLS configuration node certificates. You won't actually need to set this one up unless you're actually using secure connections, but it's good to know where it lives. Similar deal with a HTTP proxy configuration node. This is used if your Node-RED instance needs to route web requests through a proxy server. This is common in corporate networks. You configure the proxy address, port, and authentication, then HTTP request nodes can use that config to route all of their requests through that proxy. Again, not something you wire into a flow, it lives in the configuration in the HTTP related nodes. So if you're behind a proxy, this is how you handle it. Most home users will not need this, but if you're running Node-RED at work or behind a corporate firewall, this one's essential. Yay, now we're getting into the good stuff. MQTT is a lightweight pub sub-protocol which stands for publish and subscribe. It's massively popular in IoT and smart homes. If you've seen my What the Heck is MQTT video, you'll know all about it. The MQTT in node connects to an MQTT broker and subscribes to a topic or a wildcard. Whenever a message is published to that topic, this node outputs it as a Node-RED message. In the config, you set your broker connection and the topic you want to subscribe to. After deploying, every time something arrives on that topic, you'll get a message with the payload and the topic. I use these constantly in my smart home. They're really good for sensor data and device messages, and everything comes in through the MQTT in node. And MQTT out is the flip side. It publishes messages to MQTT topics. Again, you configure the broker and the topic just like you do with MQTT in. When a Node-RED message arrives at an MQTT out node, its payload gets published to that MQTT topic. This is how you send commands to devices or other systems via MQTT, like publishing on to home device 1 command to turn something on. So MQTT out is how you send data to MQTT topics. Together, MQTT in and out let Node-RED bridge to all of your IoT devices and services using PubSub. This is an absolute workhorse in any IoT setup. Let me show you a quick example of these in action. Before we touch anything, we need to have an MQTT broker configured. I'm not going to show you how to do that because that's out of the scope of this video, but it's relatively straightforward to set up. If you check out my What the Heck is MQTT video, that should give you a good bit of guidance on how to get started. But what we need is a configuration node that'll actually show us it. So if we look at this configuration node here, I've set this one up already, but you can see it's pointing to an internal Docker one. That's just because I've set one quickly up for this test. I'm not going to go in to MQTT configuration. So again, I've covered that in What the Heck is MQTT. So again, this is just me telling you, you need a configuration node set up, pointing to your MQTT broker for this to work. Configure on's really easy though. You just need to set the address for the server and the port. It's usually 1883 unless you're using a secure one. You also need to set your protocol, which is dependent on the server you're using. So this isn't something I'll be able to tell you which one is the right one. I've just left mine at 3.1.1, which is the default, and that's absolutely fine. Client ID, you can set a client ID here if you want to. So normally the client ID would be something like Node-RED server or something like that. Basically, it's just a little identifier to say, anytime a message comes from here, attach this client ID to it. It's usually not necessary, but it's handy for like categorizing things so you can see where things are coming from. Keep alive is just saying keep the server alive for like, in this instance, 60 seconds. So keep the connection open for 60 seconds. And then every time we do it, we're using a clean session, so we're not getting pollutions from the previous one. There's no security on this one, so you don't have to worry about that. And messages, that's basically your birth message, your close message, your will message, so birth, death, and will. I'm not going to explain those. Again, the What the Heck is MQTT video will tell you all about those. So the first demo is your kind of bread and butter one. This is what you'll do most of the time. So you'll notice that these two things are not connected to each other. So we're looking on the debug panel, we are looking for message.payloads output, and in the input, in the inject node, we're sending 21 as our message payload. And when we click that, 21 indeed appears in the debug panel. The reason why this works is because we've got an MQTT out node here and an MQTT in node here. The MQTT out node is publishing to our home broker that we set up in the config, and that's sending 21, the payload, to the topic home/kitchen/temperature. And this one is an MQTT in node, which is listening to the server that we set up earlier on the topic home kitchen temperature. And that's why that works. So basically this is sending something out and this is listening to the things coming in. Now dynamic topics are really handy. So this one, if you look, the topic is blank. Now that's not a mistake, but if you leave the topic blank, it will just assume that anything you send to message.topic is the topic that you want. So if we look at here, we are sending message.topic sensors kitchen temperature, and we're sending the value, the payload of 21. So this is the same as this one, except we're also adding the topic. So instead of the topic being configured here, the topic is being configured in the inject node. So that means that we can send sensors kitchen temperature 21, and we can also send sensors garage door equals open, because that is just publishing whatever it gets here. Now this one is listening, and this is called a wildcard topic. So this is listening to anything that starts with sensors. So sensors garage door, that's covered. Sensors kitchen temperature, that's covered. So either topic will be set. Just to give you an idea of how flexible this is, we can just create a new one. And if we copy this, say loft hatch, message.payload open, sensors, loft, hatch. And because that starts with sensors, it'll still work, we'll still get it. This is ridiculously handy in Home Assistant because you can just listen to any topic. Home Assistant will actually start a topic in MQTT with Home Assistant. So you can just listen to any topic, or you can do subsets, so you can listen to anything from a room, like Home Assistant / kitchen. It's incredibly handy. So this one's a bit of a hidden gem. A lot of people don't know this is here. So MQTT in and MQTT out sounds like they're the beginning and end of a flow, which they kind of are. But if you look on here, action, subscribe to a single topic. If you click the drop down, there's also dynamic subscription, and then the topic just disappears, it goes away. So here's one that we set up earlier. This is set to dynamic subscription. And if you look, there's an in and an out. It's now part of the flow, which is incredibly powerful, because what we can do with this is we can say message.action equals subscribe, message.topic equals lights. So that is now going to update that and set the topic. So if we clear this, and then we click on subscribe to lights, now this is listening for lights. So if we publish to lights kitchen, we will see it. How handy is that? You can even click on list subscriptions, and list subscriptions will basically say message.action get subscriptions, which is another property available in this node. And then that will tell us which ones are subscribed to it. We can also do message.action unsubscribe, and that will just clear all the subscriptions. So if we click on that again, we get nothing. This is something that I did not know existed until I was researching this video. It is incredibly useful. Its use case is kind of niche, not gonna lie, but the times where it would be useful, this would be really valuable. A quick thing I want to point out before we finish this demo. So when I was setting this demo up, I accidentally made a bit of a mistake, which I then fixed, but I realized that this is probably something worth showing you. So in here, I changed these to sensors kitchen temperature, but in this one, these were home kitchen temperature. If I change this to home, so now when we click kitchen is 21, we get it twice. And that's because this is listening to home kitchen temperature, and this one is listening to anything under home. So just bear that in mind. It's really easy to actually make that mistake and accidentally make your topics a little bit too vague. So just bear that in mind. So that's simple, but incredibly powerful. It's basically how my entire smart home communicates. The HTTP in node creates a web endpoint on your Node-RED server that can receive HTTP requests. You configure a URL path and a method like get or post, and when someone hits that URL, this node outputs a message representing the request. You get all of the details, the headers, query parameters, the body, everything. This lets Node-RED act like a web server or an API endpoint. This is really useful for like webhooks or accepting web service calls or even responding to web browsers. An important bit is that a HTTP in node should be paired with a HTTP response node in order to send a reply back. Otherwise, the client just hangs around waiting for a response. So you'll typically have HTTP in at the start of a flow, do some processing, and then end with HTTP response. Speaking of which, HTTP response sends the reply back to whoever made the request. Whatever message reaches the HTTP response node, its payload becomes the response body. You can also set status codes and headers via message properties. For example, if HTTP in handles a form submission, your flow processes it, then HTTP response sends back a confirmation message or JSON data. Without HTTP response, the client would hang, so it's crucial. HTTP response closes the transaction. Together, HTTP in and HTTP response let you build RESTful APIs or webhooks right in Node-RED. Now, HTTP request is the opposite. It makes outgoing HTTP requests. This is Node-RED acting as a client calling external APIs. You configure the URL and the method, and then the headers and the authentication. When a message hits this node, it sends the HTTP request and waits for the response. The response comes back as the output message, usually within the body and message.payload. I use this one for calling web services, things like a weather API or triggering webhooks or pulling data from REST APIs. It's basically Node-RED's fetch data from the web node. This is extremely useful for integrating with pretty much any web-based service. WebSocket nodes handle real-time bidirectional WebSocket communication. WebSocket in can either listen for incoming WebSocket connections, basically acting as a server, or connect out to an external WebSocket URL as a client. When data is received over the socket, WebSocket in outputs a message. Going the other way, WebSocket out sends messages out to the connection, either broadcasting to all connected clients if you're in server mode, or to the server you're connected to in client mode. WebSockets are amazing for real-time applications. They can stream data to web dashboards, push notifications to browsers, or interface with services that support WebSocket. Think of it like MQTT but without a broker. It's a direct, persistent two-way communication. I've used these before for live dashboard updates where I want instant data without having to poll for it. The TCP nodes let you work with raw TCP socket connections. TCP in can operate as a server, listening on a port, or as a client connecting out to a TCP server. In server mode, each new client connection generates messages. In client mode, you initiate the connection and then receive incoming data. TCP out sends data over a TCP connection. You typically pair it with TCP in. These nodes work at the byte stream level, so you may need to handle your own framing. Use cases are things like interfacing with custom hardware protocols, legacy systems, or any device that communicates via raw TCP sockets. Finally, UDP nodes handle connectionless UDP packets. UDP in listens on a port for incoming datagrams, which is useful for broadcast messages or UDP-based sensors. Each packet becomes a message. UDP out sends a single UDP packet to a specified host and port. UDP is simpler than TCP because there's no sustained connection, it's just fire and forget. You can use it for protocols that use UDP, like wake on LAN packets, receiving LAN broadcasts, or talking to IoT devices using UDP for telemetry. I've actually used UDP out for wake on LAN to turn machines on remotely. It's really simple for that kind of thing. Okay, so that's the network nodes covered. This is the entire communication layer. You've got MQTT for pub sub IoT messaging, HTTP for web APIs and webhooks, and then WebSockets for real-time bidirectional comms. And you can use TCP and UDP for lower-level socket work, plus the TLS and Proxy Configs for securing and routing connections. These nodes are what make Node-RED so powerful for integration work. You can basically get it to talk to anything. In part 3, we'll wrap up with parser, sequence, and storage nodes, so data formats like CSV and JSON, message batching and splitting, and file operations. If you're finding this series useful, hit the like button and don't forget to subscribe. I'll see you in part 3. If you're keen to know more about MQTT, I highly recommend you check out my What the Heck is MQTT video. Link right here. Ta!